I'm Matt Venn. This is another interview for the Zero to ASIC channel, this time with Tim Edwards, who I'm sure a lot of you already know. So Tim, could you just introduce yourself briefly for people that haven't heard of you already?
Yes, I'm Tim Edwards. I'm currently working for eFabless. My official title there is Vice President of Analog and Platform. I have been doing open source software, and probably most people know me as the developer of tools like Magic and NetGen and so on with the website opencircuitdesign.com. And I've been doing that for many years.
Yeah, in fact, it was Qflow that was my very first introduction to VLSI, so I followed the Qflow tutorials. So what I wanted to talk about in this interview was just like the next steps. So we had the deadline in early December for everyone on the first shuttle to send their final files in. And now there's like a bit of intermediary stuff that is happening before those files all get sent off to Skywater. Is that right?
Yes, that's right. And I've been asked about that before on the Slack channel, and I said, you probably don't want to know all the details of what's going on behind the scenes.
It's like making sausages.
Exactly. And it's for this particular one, this is the first time we've done it. Some aspects of it are nothing short of revolutionary. The whole idea of everything that is going into the manufacturer is open source, and on a public repository is making it a particular challenge for us. So there is a lot of infrastructure stuff going on, and most of that has to do with making automated scripts that will do things like go out to each of the repositories and pick up whatever the latest version of each person's project or each group's project and pull that data in. And that in itself is a big challenge. And we have this website set up now, or some web pages set up with forms and so on the eFabless site where each user can go in and run their set of checks and tell the server where to find the open source projects. And so we have been grabbing those, and anytime it's updated, people let us know, we go grab it again. There's a lot of data going back and forth, and we've run into additional challenges, like there's a limit to the size of files you can put into GitHub, which is a direct conflict with the fact that once you take some of these projects and create GDS and then add fill, they can be anywhere from 1 to 2 gigabytes.
Whoa.
In size of data, uncompressed. So we're doing all sorts of looking into the problems of, okay, can we compress this? Is that small enough file size? And I think our current push right now is to move stuff over to GitLab, which has fewer constraints like that than GitHub did, and is going to make it a bit easier to deal with some of these files.
I've got just two questions that come up based off the back of what you said. Was one, you said what's happening now is quite revolutionary. Is the revolutionary part of it the fact that everything is open source down to the GDS?
Yes, yeah, I'd say so. I mean, there's nothing revolutionary about doing a shuttle run or having a third party like us managing the shuttle run for a foundry. That was what Moses was doing for a long time, but it happens that the major proponents for open source tooling at Moses retired a few years back, and Moses has been slowly drifting away from the open source aspects and are more into the commercial tooling right now. So I had always wanted to do that sort of thing. I felt like there was plenty of opportunity for another organization to be doing the same sort of thing that Moses had been doing, but there was no open source PDKs. That made it virtually impossible to do the same sort of thing, other than just duplicating what Moses was doing, which, well, of course, that would just be stepping on their toes. There's no point in that. So the fact that there is now an open source PDK is what makes it possible for another company like us to jump in and make that same sort of thing available, as it is becoming less available through places like Moses.
Okay. And the second question was about the file sizes, because I was wondering why we didn't submit, because all the tooling is open source. Why not submit the precursors rather than the final GDS? So send you the like the directory that goes into OpenLane, and then you would run that, generate the macro block, put that inside Caravel, and that would be the final GDS.
Well, yes. In fact, that is Tim Ansell's vision, and that's what he wanted to do originally, was that it would all be source, in a sense, and everything follows from that, and you can always be guaranteed of getting the exact same result in the end that you put in from all the source code in the beginning. That is an honorable goal. It is currently impractical for a number of reasons, and the main reason is that the tools are not perfect. They will generate errors, and some of those we have no automated way to work around at the moment, which means there will be some manual intervention between what the tools compile and what final result is acceptable to the foundry for manufacture.
So pushing some of that work onto people like me that make an application makes a lot of sense, because it means that you don't have to do it all.
But what that means is that breaks the automation in the chain, is that there is a point in which you say, all right, this is as far as the automated tools can get us at the moment, and now there's a manual intervention. And perhaps if we took some approach like Git and say, okay, here's the differences between the manual and the automated process, and apply that as a patch or something. But there's a considerable amount of infrastructure work to be done there. I can see it happening in the future. It's not going to happen for this tape out. But yes, I agree. What you really want in the repositories is what is essentially source code for a chip. Mm-hmm. And you don't want all the messy details. You want anything that can be absolutely created exactly from the source and create a manufacturable piece of silicon. That's the way that you want it to be. And you don't want to have to save that 1 or 2 gigabyte file somewhere up in a Git repo. You just want the source codes.
Okay.
There's a second reason for it, though, which is that there are multiple tool chains here. So the one that you described, which is you go through OpenLane, you provide all the Verilog sources to OpenLane, and OpenLane takes it through top level assembly and routing. Assuming that you can get around the errors and things that I said that are potentially possible to end up in there and have to be manually fixed before you do the tape out, that is at least a consistent flow end to end. There's no reason why you can't just say, okay, here's the Verilog source. All you have to do is press a button and you will have manufacturable GDS. But there are other flows in there. So there are people who are doing analog, mm-hmm. and there are people who are doing mixed signal designs, and each one of those has a different flow. And some of the flows, there are people who are using the open tools for the flows, and there are people who are using closed source tools for the flow. And that also presents a problem, because Google would like to have everything from source, meaning that you would plug the source in, you get your GDS out. But if somebody has used a closed source flow for that, then you cannot be guaranteed to be getting the same GDS output at the end, mm-hmm. that person did with their closed source tooling.
I've started asking the people I interview to go to zerotoasic.com/terminology and choose a term that they like or suggest something that I'm missing. And Tim Edwards spotted that I was missing PEX, or parasitic extraction. So to learn more about that, head on over to the website and check it out. So now you've got your scripts that are scraping all these GDS2 files out of our repositories. What's the next step?
I have written a 3-part set of scripts that we run on our end, which does the following things. The first one is responsible for applying a user ID. So in order to make sure that we are tracking each project uniquely, we give it a 8 hex digit assigned number, and then that will, so each project is supposed to have the Caravel chip inside it, and so each chip looks like the Caravel project but has something else in the user project area. As far as Skywater is concerned with it, it will come to them as a project called Caravel underscore with an 8 hex digit number behind it. That 8 hex digit number is going to be placed on in metal 5 on the top of the chip where it can be seen when you turn the die over. And it will be encoded in a register inside the chip so that you can do an SPI transfer and get that number back. So regardless of whether you are working on a development board or staring at the die, you can tell which project you're looking at based on the chip. So that should help with, of course, whoever's doing the third-party pick and place and packaging and mailing these things out will need to have that information to know that they are sending the right chip to the right person. And
that's cool that you can see it optically as well as fetch the
information. It's all
out.
bookkeeping, but it's important bookkeeping.
And the way that you're encoding the ID electronically, is that like with just kind of 1 or 0 connections, but like made on metal layers, or are you doing that with placing transistors or?
Actually, it's called via programming, which means that somewhere in the GDS you have a via, and if you put it here, it makes a 1, and if you put it there, it makes a 0.
Cool.
And the Skywater has a single cell that will produce a logic 1 and a logic 0, which is actually helpful in this case because I don't have to do things like replacing cells. In that all I need to do is have a wire that's going over top both the 1 output and the 0 output, and then whether I place a via on one or the other, it's immediately programmed to a 1 or 0. So I just it's a really simple script. It just goes in, directly modifies the GDS. It looks through the GDS until it finds the binary code that represents one of those vias, and then it knows which one it's looking at and switches the via.
And did you just place however many of those 8 times 8 cells in a long line or something, and then know exactly where the coordinates are?
No, actually that was done with OpenLane.
Okay.
It was a synthesized cell. So it was synthesized first, and then I modified it to make sure that I could access both the 1 and 0 outputs for each of those cells. They're only 32-bit, so it wasn't a huge amount of work to do that.
Cool.
So that's the first script.
Okay.
The second script is doing the fill generation, which has been a big issue largely because of the amount of work required to do the fill generation algorithm and the complexity of the fill generation algorithm that Skywater uses and the constraints that Skywater is applying to the amount of fill that they want us to have.
So fill is where you're not allowed to leave big blank spaces on any of the layers, is that correct?
That's right. It's a planarization process, and it's actually done by mechanical polishing. So each layer, after you apply the metal layer, you polish it flat, and then apply the second metal layer and the third metal layer and so forth. If you have a consistent amount of metal on that layer, then it's very easy to polish it flat. If you have large gaps missing in the metal layer, then you will often have a kind of dip in the top level of...
So it's in some ways it's almost like the fill patterns that you used to have to use for PCB manufacture, where like to get consistent etching, you want kind of you don't want to have like big blocks of copper and then empty spaces.
I'm actually not that familiar with the printed circuit board manufacturer,
I guess it's,
yes, that's the general
analogous,
idea.
Even though they're two completely different processes.
Yes, exactly.
Okay. So is that like hatching or just big blocks of metal, or?
As I said, it's a complicated process. They have a algorithm for it that is described in the documentation that is part of the open source offering. So all of that is up on the website, and you could look through it if you actually feel like it.
Yeah.
But it's like a multi-pass algorithm in which they will find the large blank areas and fill with large square blocks, and then do a second pass and look for smaller areas and fill those in with smaller blocks. And then for the diffusion and poly, what they call FOM, is done multi-pass, so that you have diffusion and then poly, then more diffusion, then more poly, and then smaller diffusion. It's as I said, it's complicated, and it's probably not worth thinking about too hard.
Yeah.
And we're going to be doing several iterations back and forth with Skywater to make sure that we've got that correct.
Will that eventually go into open lane, or is this too specific to Skywater process to make it worth building into the tools?
Oh, it is being built into the tools.
Okay.
In fact, this is further upstream in Open Road, but Andrew Kang was asking me the other day about where to find all the information about fill patterns, because he wanted to put that into Open Road, and is, as far as I know, doing that right now.
Okay, cool. So we're up to number 2.
Yes, so the final one is the compositing, which is probably the simplest step of the 3. It's just to make sure that you take all of the GDS for the project, for Caravel, for the user project, for the fill patterns, and for the user ID, logo, and so forth, and stick that all together and generate your final GDS.
Okay. So up until that point, you've actually got separate files, and then you're going to merge them all together, basically.
Right. It could all be done in one file, but generally speaking, if you have to process the same file and you just keep growing the file, then your processing just keeps getting slower and slower. So I try to keep them separate as much as possible, just because it speeds up the processing, and then assemble it all at the end.
Okay. And do you use Magic to do the assembly, or are you using something else?
Yes, I do.
Okay. It's a real Swiss Army knife, that tool.
It is, yes. And kudos to John Osterhout for writing it in such a way that it is, in fact, useful for so many different things.
Yeah, and still useful, yeah. Okay, so then after the compositing stage, is that then kind of officially ready to send to Skywater?
Not quite. So after that, we have one more step, which is to pass it through Calibre. And that being a closed source commercial tool, we would like to get that out of the flow, but at least for the first few shuttle runs, I think it's going to be an integral part of our process, and a necessary one, because we just don't trust the open source tools that much. Because there are still bugs in the tech files and so forth that I'm still working on. We found one yesterday, which was dropping little bits of implant layers where we don't want them, and generating DRC errors. And Magic does not catch that, because Magic is generating it, not checking it. And Calibre was catching it.
So Calibre's a DRC checking tool?
Yes, Calibre is also a Swiss Army knife and can do a number of things. But in this case, yes, we're using it for DRC.
Okay. So then there's a potential that shuttle applicants like myself might need to do another round of work, or is it all out of our hands now?
There is always that possibility, yeah. And it really depends on how good the tech file is at the time that you last generated GDS, and if there were any major errors found and we had to go back and adjust the tech file to correct them, and we discover that there is no way to fix that automatically, we might have to go back to the users and say, okay, you need to update Magic, you need to update Open PDKs, you need to rewrite GDS. We hope not to have to do that.
Yeah.
So far, it looks like most of the issues are on our end and shouldn't affect the users, but I wouldn't say no, that's never going to happen.
Okay.
I just don't want it to happen.
Fingers crossed.
I don't want to have to go back to the users and say, no, you're not quite finished yet.
Just on the topic of DRC, so when we did our final submission, the kind of allowable number was something like 140 or something like that, and those were DRC issues within the Caravel harness itself. Is that something that you've also been working on, getting that down to 0?
It is. Getting it down to 0 is a challenge. It is mostly due to the fact that Magic has its own database format. One of the essential features of Magic is that if you have a device, it wants to have a special layer for that device, such as a regular infet is its own layer type, but so is a infet with a low threshold voltage. So that's another device type, which means that if you want it to recognize the device correctly, you have to have all the layers that go into recognizing that device as being a unique device type in the same cell. And a lot of commercial tools work differently. They will put all those different layers in different cells. So you might have a generic FET in one cell, and then you put the NWEL that makes it a PFET in another cell. And that sort of thing does not work well with Magic. And I am looking for different features that I can add to Magic to work around those issues. But the problem is that that kind of splitting up of a device into different layers, different cells, can be done in different ways, such that one way it only works if you're looking at it top down, and another way it only works if you're looking at it bottom up. And so I've been slowly working on that problem, and it is getting better, but not completely done yet. The alternative to that is that in Magic you create what I consider abstract views, not quite like Left, but just you're looking at a view that Magic read in, and then you manipulated it to get rid of the DRC errors. And what you get is not exactly like the GDS, but it is close enough that you can work with it and not have to worry about creating DRC errors, particularly for something like an IO cell. This is where a lot of the DRC errors that are showing up in the database are coming from, and the IO cells are just hard to get right. But if you went in and fixed all the DRC errors by hand, it wouldn't affect the user, because the user isn't ever going to be putting layout on top of the IO cells or anywhere near them. So that's one possibility, but that's time consuming. So anything I can do to just make the problem go away in the correct way without having to just go draw out all these abstract views is the better solution.
Great. Well, thanks so much for all your hard work that you're putting into this.
Yep, thank you. And I should call out all the other people at eFabless, because I'm not doing the infrastructure part. I wrote a few scripts. There are other people who are working on
mention some
how
names.
to write the scripts that go out and grab database. Oh, there's Jeff DeCorpo and Risto Bell and all the people who are at American University at Cairo, like Ahmed Ghazi and Amr Gohar. And I'm going to miss people if I start naming them all, but those are some of the major players.
Yeah. There's been it's been such a group effort, it feels.
Well, it is certainly taking up a lot of our time here at eFabless right now. It's our major project to get through and make sure it gets done in reasonable time. And it's clearly going to be the fact that for the first tape out, and probably the second one too, it's going to take way longer than anyone would want, but that's how it is to try to get this thing up from ground up.
When you're doing something new. Any idea when the files are going to get sent to Skywater?
I would expect that we are maybe a week away from being able to start sending them the first files and letting them check. So it's really a matter of what happens when we push these things through Calibre after having corrected what we see as the obvious major errors. And then as far as I know, since we have Calibre running on the back end of all this, if we can get Calibre to the point where Calibre is saying it is clean enough, and enough means it's producing errors, but Skywater is saying all those errors are waivable, then at that point we can just push it out to Skywater and they will take it. So that's right now the process is seeing what comes back from Calibre and are there things in there that have to be fixed. And then, as I mentioned before, that's the problem where you may have to go back to the user and hopefully not, or you may have to fix it internally. And I see that as taking maybe a couple more weeks. On a optimistic side, maybe we can get it done in a week.
Fantastic. Well, we'll keep you posted. As in you, the audience, not you, Tim. You'll keep me posted.
Yeah, indeed I will. And the Slack channel is there for that.
Yeah.
And I'm always around somewhere answering questions.
Yeah. Okay, well, thanks so much for your time again, Tim. It's been great talking to you. And have a great
well,
rest
thank
of
you
your
for
day.
the interview. And I'm happy to reveal all the details of what we're doing behind the scenes. And hope we can do it again.
Absolutely.
Okay.
Thank you.
All right. Take care then.